Algorithms is not yet another course that you have to go through grinding your teeth in computer science. Algorithms is a foundational course. How good a computer science person you are will be determined by how good you are in algorithms. Not by how good you are at tampering with the box called computer. Even though we do not despise that. That is the point of this quote. In this introduction, I will emphasize or highlight three important ideas or words. One is design, two is correctness by construction, and three is efficiency of algorithms. We are interested in designing algorithms. We are interested in constructing the algorithms. In the course of in course of time, you will appreciate the difference between design and construction. Importantly, we are also interested in the efficiency or the performance of the algorithm. Algorithms are solutions to computational problems. Not all problems of mankind can be solved by algorithms. In fact, what we can solve with algorithms is a very small set of problems of mankind. The kind of problems which can be tackled with algorithms we call computational problems or algorithmic problems. So for the rest of the 45 minutes, a brief introduction about how we design algorithm, how we construct an algorithm which will be correct, and how would we calculate the efficiency of the algorithm. Algorithm design is a creative work. It is not a mechanical work. Like writing a piece of poetry is creative, or writing a fiction is creative, or composing a music piece is creative. Algorithm design is a creative process. On the one hand, it is very exhilarating to know that algorithm design is a creative process. On the other hand, it is a little depressing because only those who are gifted for that creative work will be able to design algorithms. Fortunately, it is not completely true. There is a good number of algorithm design strategies which anyone can learn to apply for solving computational problems. This is the good news. Follow me carefully. Strictly speaking, algorithm design is a creative work. But the saving grace is that for quite a useful number of algorithmic problems or computational problems, we can design and come up with an algorithm using a small set of strategies, such as decrease and conquer, divide and conquer, exhaustive search, dynamic programming, local search, and so on. We will elaborate on those matters later on. The important point, the crucial point is, it is creative on the one hand and application of strategies on the other hand. Therefore, it is a combination of both. Our first approach would be, given an algorithmic problem, can I wield any of the design strategies that I know to solve the problem? If the given problem does not lend itself for any of the known design strategies, only then I resort to a creative work. What is a computational problem? And what is an algorithm? A computational problem is specified or defined by an input, an output, and the relation between the input and the output. Whether we know in this course how to design and construct algorithms or not, at least we should know how to specify a problem. Do not despise it. Very often, our problem solving is almost equivalent to a blind man searching in the dark room for a black cat which is not there. We do not even know the problem well, but we are trying to solve the problem. Therefore, the most critical and important step is specify the problem. How do we specify? What is the input to the problem? What is the output of the problem? Let me elaborate. What is the input? The input given to the problem should satisfy certain properties. We call it the precondition. So the problem requires that the input satisfies the precondition. And the problem solver or the algorithm designer has the responsibility to produce an output which satisfies certain relationship with the input. So the algorithm designer can require that the input satisfies the precondition and has to ensure that the output, strictly speaking, the relationship between the input and the output must satisfy what we call a postcondition. So technical words are actually precondition of the input, postcondition of the output. Informally, instead of using that ornate words precondition and postcondition, I will use the simple words input and output. But be careful. Whenever I use the words input and output, I actually mean precondition and postcondition. Postcondition is the relation between the input and output. Given a computational problem, we design and construct an algorithm to solve the computational problem. What is an algorithm? In simple words, an algorithm is a sequence of well-defined, unambiguous instructions for solving the problem. What do we mean or understand by solving the problem? The input satisfies the precondition. On executing the instructions of the algorithm, the output will satisfy the postcondition. And this will be accomplished in a finite amount of time. A well-defined computational procedure is composed of a finite number of computational steps. Each step should be definite. It means it is precise. It should be effective. Each step is executable. That solves the problem by executing the steps. And the algorithm execution should be finite. The algorithm execution should terminate in a finite number of steps. Okay, so an algorithm is a procedure, a sequence of instructions to solve the problem. And we may also say it is a recipe for solving the problem. And we need a notation, if you want, use the word language, for writing down this notation, writing down this recipe. There are several options. We can write down the recipe, this algorithm in plain English.